Imagine a calculator that can't accept the numbers you type in or display an answer on the screen. It would be entirely useless. A Python script without input and output works the same way. It needs raw materials to process and a way to deliver the finished product. Today, we are going to fix that by building a fully interactive mathematical mini-program from scratch. Before we start, make sure you are comfortable with variables and data types. We will rely on those concepts to hold the information we pass back and forth. Moving data into and out of your code is the first step to solving any algorithm on modern coding platforms. Without it, your programs cannot interact with users or testing environments. We will start with output. When we want Python to display information on the screen, we use the print function. By typing print followed by text inside parentheses, Python outputs exactly what we wrote to the terminal. You don't have to limit yourself to just text. You can place variables and numbers directly inside those parentheses. Instead of printing the variable's name, Python retrieves and displays the value stored inside of it. When you print multiple values together, Python automatically inserts a space between them. This helps keep your results readable right out of the box. But you have to be precise with your syntax. If you type the word hello without quotation marks, Python thinks you are trying to print a variable named hello. Since that variable doesn't exist, it throws an error. Wrapping your text in quotation marks tells Python to treat it as a literal string of text. The presence or absence of quotation marks is the only way Python knows whether it should display a message or execute a stored instruction. Sometimes Python's default formatting doesn't fit your needs. You can change how functions like print behave by passing in specific parameters. In this terminal comparison, you can see how we use the sep parameter to change the automatic spacing. Setting sep to a pipe symbol replaces the default spaces with a custom character, neatly dividing our outputs. You also have the end parameter. Normally, every new print statement drops down to a new line. By adjusting end, you force Python to keep printing directly on the exact same line. Controlling these formatting parameters gives you precise control over your display, making your scripts look clean and professional. Now that our code can speak, we need to make it listen. We capture user data using the input function. When Python reaches an input command, the entire program pauses. It stops executing code and waits for the user to type something. Once the user types their text and hits enter, the program wakes back up. It takes exactly what was typed and stores it into a variable for later use. Python is strictly case-sensitive. Capitalizing the first letter of print or input will immediately break your code. You have to use entirely lowercase letters for these built-in functions to work. By utilizing this function, your program stops running a static list of commands and actively reacts to the person sitting at the keyboard. Let's put this into practice. We are going to build a small addition calculator that asks the user for two inputs, let's say 10 and 20. If we just run the input commands and add the variables, the output isn't 30, it's 1020. Instead of doing math, Python takes the 10 and the 20 and simply mashes them together side by side. This happens because the input function always packages user entries as text strings. Even if you type a number, Python treats it like a word. We can verify this behavior by checking the data type. Python explicitly tells us that our numbers are currently classified as string objects. To fix this, we use a process called type conversion. By wrapping our input variables inside an integer function, or int, we force Python to translate that text back into a true number. Now when we tell Python to add them together, it recognizes their numerical value and correctly calculates 30. Computers cannot guess your intent. Because they don't infer mathematics from text blocks, explicit data type conversion is a necessary step whenever you process numerical logic. We have all the pieces. Now we merge our prompts, type conversions, and formatted outputs into a single application loop. You can speed this up by accepting multiple variable inputs simultaneously on a single line of code. If a user types 10 space 20, you assign those values to A and B at the same time. Mastering this sequence, prompt, process, and return, gives you the basic template needed to make any internal logic usable by a person sitting at a screen. Here is our finished interactive session. We present a clear prompt, capture the user's input, perform our math, and return a perfectly formatted mathematical result. When you test your code on a competitive programming platform, this exact pipeline is happening in the background. The platform feeds arrays and matrices into your algorithm as input and checks your final output. Next time, we'll dive into Python operators to see how you can perform complex logic on these captured inputs. Every program we write from here on will depend on these basics to move data. Without I/O, even the most complex algorithms would remain trapped inside the source code, unable to receive data or deliver answers.